Now, I'm sort of bending the rules a little bit. I'm going to show you a result. I'm going to prove it to you in a very, very quick way that is suitable for where you're at mathematically. There are more sophisticated proofs for it, so you'll just have to trust me for now, okay? Would you please draw for me a triangle? Right angled. Like so. Doesn't have to be beautiful, doesn't even have to be that big. I would like to make its hypotenuse 1. And I'm just going to call this angle over here in the corner, just going to call it theta. That's a pretty standard name for angles that I don't know what they're equal to. Alright, now on the basis of this information, okay, I would like to know, what is this side over here? What is the length of this side? Now you have very little information. You don't even know the size of the angle, okay? But it's trigonometric fallacy, right? So you can use some trig to help you. It's a right angled triangle, okay? So suppose, let me just call this side x, okay? Don't know what it is. But look, use your trigonometric knowledge. What kind of equation, I should say, could you write on the basis of what you know here? Okay, you look at the two sides you got. In relation to the angle, it's opposite and hypotenuse, right? So that's sine, isn't it? Okay, so I can say sine theta equals x over 1, that's the ratio, which of course is just x. Okay. So now I know what this side is equal to. It's equal to sine theta, whatever that happens to be. Are you comfortable with that idea? You see that? So I'm just going to relabel that. Just going to call that sine theta, because x equals sine theta. Okay, without writing anything down, and not having to call this like a letter, what do you think this is equal to? It's the adjacent side, right? Let me show you the steps just in case you're not sure. Let's call it something else, right? Adjacent hypotenuse, right? So cos theta is adjacent over hypotenuse, which is 1. Y equals cos theta. So I'm just going to relabel that. Happy times. You right so far? Okay. Cool. Now, by the way, as I said, just like with this proof, if you see the aha moment, okay, don't spoil it for everyone. There's actually a couple of different moments here you have to watch out for, right? Just process it, maybe make a mental note for yourself, like, aha, here's where it is. Okay.
Wait, is that all right though?
So far, so good. Now, have a look at this. It's a right angled triangle, right? So more than just all this trig stuff, you can make some statements on it based on the fact that it's right angled. What might you say? Okay, you got Pythagoras here, right? What does Pythagoras tell you in this particular triangle?
Sine squared plus cos theta squared equals 1 squared.
Very good. Sine squared plus cos squared equals 1. Okay? Now, I have given you the quick and dirty proof for this. I've drawn you a triangle. Okay? But this is actually a very important result. This is not the problem, by the way. This is a well-known result. In fact, it's called the Pythagorean identity because it comes from Pythagoras. Okay? So this is true. You can get a whole bunch of variations on this if you divide through by cos squared or divide through by sine squared. It's aside from the point. Yes?
Why have you put the square next to the sine and not after?
Sure. Okay. So that's just a matter of notation. I want to avoid this kind of situation, which is kind of ambiguous, because am I squaring the theta or am I squaring the sine theta?
The whole thing.
Right? So when I say this, I mean this. Okay? Because even though the whole thing is squared, so really I should put it over there. It's so common to do this, and I want to avoid brackets because, as you'll see in a second, sometimes I've just got brackets flying everywhere. So if I can minimize them, that's the idea. So that's just a little bit of notation for you. So far, so good. Now, get ready. I'm going to start playing around. First thing I'm going to do, I move this guy, cart him over the other side. Right? So cos squared equals 1 minus sine squared. Okay. That's a square. Okay, so just for the sake of it, I'm going to take the square root on both sides. Okay. Remember, if you see something, just keep it to yourself for now. Okay. That's fine. Both are positive, like positive, positive. So far, so good. Okay. But theta, right? Theta is an angle. I don't know what the angle is. So I can actually put different angles into them. Let me just give you an example. Consider, what would happen if theta were 180 degrees? Okay, what would happen? Now the thing is, you can use a calculator, but hopefully you know a little bit about sine and cos to actually know what they're equal to when theta is equal to 180 degrees. Okay, have you guys seen your trig graphs yet? Have you seen them? Yeah? Okay, good. All right, that's going to be my way in. That's the easiest way to have a look at it. Here's sine, okay? And here is cos, right? Now, I've just drawn what we call one period of each of the graphs. If I keep going, I'm going to go repeat the same shape over and over again. This point here, this end point is 360 degrees. Okay, so where's 180?
At the.
For this one, it's right in the middle. Okay. For this one, it happens to be down here. Okay. Now, I'll just save a bit of time. This is -1. Okay, that's the bottom of that graph. All right. So what happens? Well, cos of 180 degrees equals the square root of 1 minus sine squared of 180 degrees. You see what I mean by the brackets flying around? Okay. Cos 180. 1 minus 0 squared Now this was just as many lines as the other one, but remember I said that was the easiest one, okay? If you think you have found something, I'll give you a caution, okay? I'll come around and have a look at your suggested reasons for why this is a fallacy, because it is, okay? But I'll give you a tip right now. I can almost certainly tell you it's not the first one you thought of, okay? If you're like, aha, I see the problem. There's an obvious problem to this, but actually if you work through all the maths, it's not a problem. There's something a little more sneaky.